All right, so we're going to graph logs. Log equations have vertical asymptotes. All right, hence the term vertical. You're going to have an imaginary line or a line that is vertical. And the thing with an asymptote is your graph will approach that vertical asymptote, but you're not allowed to touch it. You will get as close as mathematically possible without touching that. Okay? So let me do some problems that you'll understand. I'll reinforce what I'm saying. All right, so I just picked up an equation. And so we're going to say this is our parent function. We're just going to log base 2 of x. And so we'll graph this. Okay? So I'm going to go to my calculator and I'm going to say log base 2. So how do you actually graph a log since we haven't done it before? So I need to go over here and say control. And over here to the left of the number 1, we're going to have the log. So we're going to say log base 2 and cursor to the right and log base 2 of x. That would be my parent function. I just made up log base 2 of x. But we're going to make some transformations to this equation. Okay? But what's the easiest thing to do here? The easiest thing to do if you wanted to graph this on the paper is to do what? Go Control T for table. And I would ask you to pick some points that are on your graph. Look at this. 1, 0, 2, 1, 4, 2. Those numbers aren't going to be there every single time. But I would pick, sometimes you're only going to get 2 sets of numbers or points that are not decimals. See if you can get 2 to 3 points that are solid whole numbers, maybe a 0.5 if you wanted to, but pick some easy numbers. The graph is really not the part we're going to grade how closely. It needs to be kind of in the right area and the smooth curve. All right, so 1, 0, 2, 1, 4, 2. We're going to go to 1, 0, 1, 0, 2, 1, 4, 2. And we had a graph that's going to look something close to that right there. Okay? That's our parent function, that's our graph. Okay? But this vertical asymptote thing, let me talk to you about a vertical asymptote. How do you find it and what is it? To find the vertical asymptote, I'm going to ask you to take this portion. A lot of times we're going to have this in parentheses. You're going to take whatever is in parentheses and set it equal to 0. So on this problem, there was nothing with the x. So I would take my x and I would set it equal to 0, and that is my vertical asymptote. It is an equation of a line because it is a line. And this line actually is the y-axis. So this would be my vertical asymptote. Okay? And you would have to write it as an equation of a line because it is a line. Now here's the rule about the vertical asymptote. My graph, which is this black line, is not allowed to ever touch it. It does not touch it. Okay? It'll come as close as it can mathematically, but it will never ever make contact with this. And remember that. It does not ever touch the vertical asymptote. Your graph can't do it. All right, now let's talk about a vertical reflection. What would a vertical reflection look like this? Okay? Well, let's go back to our calculator. Go Control Escape, get rid of the table. A vertical asymptote, the vertical reflection. It's a reflection over the x-axis. And we always make our a value negative. So we're going to go Tab. And I'm going to say negative log. So we're going to say Control log, here we go, 2, log base 2 of x. Get out, and there's an x. And we're going to hit Enter. And notice how we have reflected over the x-axis. And again, the easiest way to plot that, to graph that, is go to the table, get you some points, connect the dots. All right? So there's your vertical reflection. How did we find that? We said this vertical reflection would be y equals, and we said that this a value in front of the log base 2 of x. We would put it in front. Okay? And this turned out to look something like close to that. Okay? What if we wanted to have a transformation where we shifted it up and down? Remember when we went up and down, it was the k value, it was the far number, okay? So when we do this, let me erase this, get this out of the way for you. If we try to make an adjustment, what I told you is this is usually in parentheses. It needs to be past or outside the parentheses. My k value, we could say, hey, we're going to shift it up 4 units. Or I could shift it down 4 units and go -4. And we've done the transformations before, but let's go to the calculator. And we're going to say tab, and we're going to say control, we're going to get our log, and we're going to say base 2, and we're going to say x, and notice, we're inside. My cursor is inside the parentheses. But to have a vertical shift up and down, we need to get past the parentheses. We need the cursor out of the parentheses, and now I'll go +4 like we talked about, and we hit enter. And this is taking my blue graph, and I have shifted it up. Okay, there's my vertical shift up 4 units, and I can shift it down, but it's always going to be past. It's going to be past the parentheses if you look what we're doing. Okay? What happens if I wanted to do a horizontal shift left and right? Well, most of the time when we've done a shift left or right, it has been what? Inside the parentheses squared for a quadratic. It's been inside the absolute value, okay? Or now, recently, it's been inside the radical. That's the left and right, horizontal shift. This will be also inside the parentheses. So if I wanted to do this with the calculator and say we wanted to say y equals log base 2 of x, it would have to be inside the parentheses. So let's say that we wanted to shift it to the left. We're still thinking opposite, just like we've always done. We're going to say I'm going to shift it left 3 units. We're still thinking opposite. So we'll go to our calculator. Let's clear some of this out. Let's go Control, Escape, Control, Escape, Control, Escape. Now, this is just my first guy, my parent function. So now we're going to go Tab, and we're going to say Control Log Base 2, and we're going to get into the parentheses, and we said we're going to go x plus 3, because we wanted to shift it to the left 3. And that's what happened. 1, 2, 3 units. So the transformations are being the very same thing. Your k value, past is going to go vertical up and down. Inside the parentheses is going to go left to right. In front, your a value, if you have a negative, you get a reflection over the x-axis. One more thing if you want to talk about this. Okay, let's go back to our paper. We could do this. I could give you a stretch or a compression. Okay, what would that look like? If I wanted to do a stretch or a compression, that would give you something that looks like this. Y equals 2 in front. Log base 2 of x. That would be a vertical stretch by a factor of 2. And we'll give you a quick look at this. We'll say tab, and we're going to say 2, and then we'll go to our log base 2 of x, and we'll hit enter, and that's going to stretch us by a factor of 2. Okay? All right, back to our paper. Now, what if I gave you a problem that looked like this, and I asked you to graph it? I asked you to find the vertical asymptote. I asked you to find the domain and the range. Okay? So let's do the first thing. We're going to find our vertical asymptote, because that's the easiest thing to do. To find your vertical asymptote, I'm going to ask you to take the portion that is in the parentheses. To find the vertical asymptote, take the portion that's inside the parentheses and set it equal to 0. X minus 1 equals 0. You're going to go plus 1, x equals 1. That is your equation for that line. That is your vertical asymptote. Okay? So if I'm going to do this, this would give me a line. Let's try how to do this. That's too big. Let's try to do this. It's just a regular line. And we'll see if I can shift it, move it over. That's my vertical asymptote right there. I would ask you to label it as a vertical asymptote, but there's your vertical asymptote, x equals 1. I mean, x equals 1. Yeah. Oh, that's not over 1. Sorry. There. X equals 1. There's my vertical asymptote. As far as now graphing this, we're going to go to the calculator and we're going to pick some points. So go to your calculator. Let's go home, new, and we're going to go to a graph, and we had log, control, log base 3, and inside the parentheses we had x minus 1, outside the parentheses we had a minus 1. Log base 3, x minus 1, minus 1. This should be a shift to the right 1 and down 1, if you remember your transformations. We hit enter. My graph is going to look like this. Okay? Now, what did we say? We're going to find the domain and the range, but how do I plot this? Control T to find our points. I'm looking for things that are not decimals if possible. I have 2, -1, 4, 0. 2, -1, 4, 0. Let's see if I have anything else. I can maybe see if 10, 1 fits on my graph. I'm not sure how big my graph paper is. It may not fit, okay? So I have 10, 1. 2, -1, 4, 0. That's what I want to try first. 2, -1, 4, 0. So we're over here at 2, -1, 4, 0. And I only go to 8. My graph is not big enough. So we're going to come here and we're going to get close to my vertical asymptote and work this way. Okay? Remember, our points were, let's change colors. My points were 2, -1, and 4, 0. Do your best. Just kind of graph it. Pick 2 points to go through. All right, remember, we're going to come close, but actually not touch my vertical asymptote. As far as my domain goes, here we go. We're talking about our graph. Domain, how far to the left do I go? I get really close to the number 1, but I'm not allowed to touch it. So we're going to use a soft bracket now. If I make contact and I touch the vertical asymptote, I would use a hard bracket. But since we never make contact, I have to use a soft bracket on the 1. And then we're going to go forever to positive infinity. As far as my range goes, my range will always be the same. We're going to go down forever. We're going to go up, even though it's gradual. We'll go up forever. We're going to go from negative infinity to positive infinity. There's your domain and range. Quick before we leave, how do you find your vertical asymptote? Take the portion that's in the parentheses and set it equal to 0, and that will give you your vertical asymptote. That vertical asymptote will always help you find your domain too. Okay? All right, let's talk about exponents. Now, when you graph an exponents, they have a horizontal asymptote. The logs had a vertical asymptote. These exponents are going to have a horizontal asymptote. Okay? All right, so I just made up an equation. Okay, kind of kept it kind of similar. The transformations are going to be the same almost. Look what I've done for you. This, if I have a negative in front, this is going to be a vertical reflection. Let's go on our calculator real quick. And we'll start over. We'll go home. We'll go new, no, graph, and we're going to say, okay, now we're doing exponents. So we're going to say I have 2 to the x power, and we're going to hit enter. Y equals 2 to the x. That's what your graph is going to look like. Do you remember I said we're going to have a horizontal asymptote? Okay? This horizontal asymptote is going to run right underneath here. Okay? How do you find your asymptote? Real quick, let's go get some points. We'll graph it on the other page. So we're going to say Control T and see if we can find some points. We got 1, 2, 2, 4, 3, 8. 1, 2. We'll just start right there. Let's see, go up here. We'll start with 0, 1. So I have x is 0, y is 1. Let's See if I can go any smaller. I could get 1/2, 0.25. I don't want to go 2 decimals. So I could go -1.5. I have 0.112. 0.112. I'm at 0.1. I'm at 1, 2. We said we could go -1.5. My graph will look something like this. Okay. Doesn't have to be exact. That's my parent function. That's this original guy right here. Okay? But let's talk about that horizontal thing. We talked about the exponent functions will have a horizontal asymptote. How do you find the horizontal asymptote? The horizontal asymptote will be your k value. So in this case, what is my k value? There's nothing there. I don't have a k value. So in this case, it's an invisible 0. And since it's horizontal and it touches the y-axis, in this case, you would say that my horizontal asymptote would be here to where y equals 0. It's going to be y equals in whatever your k number or your k value is. In this case, you would say that y equals 0. All right, so now you know how to find your horizontal asymptote. Let's talk a little about some transformations and what it would look like. Still, your transformations, you would put a negative in front. So let's go to our calculator, and we're going to say Control Escape real quick, get rid of that table, and we're going to say Tab, and we're going to say y equals a -2 raised to the x, and hit Enter. And there's your vertical reflection over the x-axis. Got it? Let's go back to our paper. What if we wanted to shift it up and down? My k value could be a 3, or my k value could be a -1. Let's go to the 3. Let's just shift it up and see what it looks like. Okay? So we're back into the graph, and we're going to say Tab, and we're going to say y equals 2 raised to the x. But look where my cursor is. My cursor is still an exponent. So I have to cursor to the right to bring it back down. And we're going to say +3. See, now the 3 is not as an exponent. It is back down. We hit Enter. And this shifts my graph up 3 units. Let me show you what it looks like if I left the 3 up there. Okay? So we go Tab. And we say 2. Up. And X. This, if you stay in the exponent area, this is what's going to shift your graph to the left or right. Okay? So if I put my +3 up top, instead of down level, if I left the +3 in the exponent, it's going to shift it still the opposite. Still the opposite, it's going to shift it to the left. 3 units. There you go. Transformations are pretty much the same thing as far as listing and as they go. Let's go back to our paper. All right, so we've just talked a little bit about transformations of up and down, left and right. We're going to speed this up just a tad. What if I gave you a problem like this, and I asked you for the horizontal asymptote? How do I find the horizontal asymptote? We said that you're going to find the horizontal asymptote by using your k value. In this case, you would tell me that y equals -4. So let me graph this real quick and show you how easy it is to find this horizontal asymptote. All right, so we're going to go back to the calculator, and I have -2x + 1 - 4. So we're going to get -2 to the x, back up, exponent to the x, -1. Let's get down, and we're going to say -4. Enter. This shifted. We said we were going to use the k value. We're going to use the k value to find this. All right, so it's down. My horizontal asymptote is at -4. Horizontal asymptote is at -4. Got it? Your domain. My fault. Let's go graph this thing. Let's get some points. We're going to say Control T. What do I want to use? Don't really want to use the decimals if I don't have to. But I have x is 0, it's 4.5. Y is x is 1, y is -5. So I'm going to go 1, -5, 2, -6. 1, -5, 2, -6. We're going to say 1, -5, 2, -6, and I think I saw 3, -8, but I'm not sure. So we're going to go here, and my horizontal asymptote was going to be where? I have a horizontal asymptote at -4. And we're going to come here close, and we're going to break down. Does not have to be exact. But let's talk about our domain and range now. Okay? My domain talks about going to the left and to the right. This is going to go to the left forever, which is -infinity. It's going to go to the right forever, which is +infinity. So my domain, -infinity, +infinity. Now my range, what is the high point of my graph? Excuse me, or the low point. Let's go. We can go however you want to do it. But the high point of my graph is going to get close. It's going to be close to -4, but it's never going to touch it. We're going to get close to -4, but we're not going to touch it. So we're going to get a soft bracket, and we're going to go down forever, which is going to be -infinity. Now, a lot of people want to start, when they do their range, they want to start at the smallest part. So if you see it written as -infinity to -4, that's okay. Doesn't change the answer. All right, so what did we show you today? We showed you how to find the inverse of an exponential equation. We showed you how to find the inverse of a log equation. We talked to you about graphing, some transformations. We showed you how to find a vertical asymptote and a horizontal asymptote. I know this is a lot to take in. That's why you can watch the video, back it up, and if it still bothers you, please show up in a Zoom. Please email us, ask us, let us help you. All right? Good luck.